Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macy, and today I'm interviewing Luciano Ramalho about the recent and upcoming changes in the Python language. So, Luciano, can you start by introducing yourself?
Thank you, Tobias, for having me. I'm a self-taught software developer who later in life got a degree in library and information sciences. I've been using Python since 1998. Version 1.5 was the version then. I'm now a principal consultant at ThoughtWorks, a software consultancy with offices in 14 countries, and I work in their São Paulo, Brazil office. And of course, I need to mention, I am the author of Fluent Python.
Yeah, it's definitely how I first came to know you, but I've definitely seen you around a lot of other places as well. And the fact that you went from being a self-taught developer to somebody who's so well known with having written such an iconic book for the Python community is a testament to your drive and your energy.
Oh, thank you.
And do you remember how you first got introduced to Python?
Yes, totally. It was 98. And at the time, I had left one of the first major web portals in Brazil, which was called Brazil Online. And then we did a lot of things with Perl at the time there. Perl was the language of dynamic web pages back then. PHP had just appeared. We started using PHP in some new projects. That was actually around 96. In 97, I was working as a freelancer doing web consultancy. And then in 98, I tried Java for a while, but I really didn't feel comfortable with it. So I decided to go back to Perl because Perl at the time had become object-oriented in Perl 5. And so I thought, okay, so now there's a solid, stable release of Perl that's object-oriented, and I was a big fan of object-oriented programming. So let's try that again. And then as I was reading lots of messages in the Perl mailing lists about how to do stuff, often people commented, oh, this is how they do it in Python. So the word Python, in the sense as a reference to our programming language, appeared to me in messages in a Perl mailing list where people were discussing how to do object-oriented programming in a dynamic language that has many similarities with Python. Python started object-oriented, right? It was object-oriented programming or classes and so on was not something that was bolted on to Python. It was there since 1.0. So after about the third or fourth mention of Python in the mailing list, I decided to go check it out. And I read the tutorial and I was in love with it immediately because for me, it was the combination of the best features that I thought Perl and Java had, but without the worst features that, in my opinion, those languages had. So you could write quick programs. It was very expressive and dynamic like Perl, but it was also very readable like Java, and it was really object-oriented. It felt natural to write object-oriented programs in Python as it did in Java. And so for me, it was like the combination of the best features of the two languages that I was using at the time. So it was like immediately I said, okay, this is my language. And the next opportunity I had as a freelancer to present a project to a client, I told her, it was a woman journalist, that I was going to do it in Python. She didn't care. She let me do it. And now I had a case suddenly. At the end of 98, I had a case of a news website in Brazil running on Python. And that helped me then start this whole journey with Python.
And can you give a bit more of an overview about the role that the Python language and community has played in your career since that time?
It's super important. I am now 57 years old, and I've started programming as a kid with 16 years, I think, about 16, 15. So I learned several programming languages before I learned Python, and I still do enjoy learning new programming languages, but I've never been with one favorite programming language for so long. And because I think Python there was an old slogan about Python that said, it fits my brain. And that's what I think Python does. It really fits my brain. It's natural to express solutions to problems, to many problems in Python. Of course, not all problems. Some problems are hard to express in Python. So the impact on my career was in 99, I created a company that was the first company in Brazil, as far as I know, that was doing all work in Python. And we did server-side web programming in Python. Well, we did client-side too, but it was much simpler at the time. And then afterwards, I started speaking about it at conferences. I helped organize the Brazilian Python Association, which we created to support the local teams who were doing Python events, but needed a way to collect sponsorships and sign contracts. So I and a group of Brazilian Pythonistas decided that we needed an association to help with that. And then I started, when I started going to conferences in the US. And at one of those conferences, I presented the idea of my book to O'Reilly in 2013. It took them about 2 months to respond. When they did, they said, okay, we like your book idea, let's go with it. And then after my book was published, I was hired by ThoughtWorks, which was a company that I always admired. But to be completely honest, I did not have the courage to apply for a senior position at ThoughtWorks. But they came after me. Then I went through their regular interview process. After 6 interviews and programming exercises and so on, I was accepted. I believe the fact that I had written the book was important for them to come after me. So yeah, it's been great. And now, with the success of the first edition, which was released in 2015, it has been translated. I wrote it in English, but it has been translated to 8 additional languages, and it has been published in 10 different countries. It's a big success for a book that's not an introductory book. It's more of an intermediate and advanced book, and it's opened a lot of doors for me. Last year, I was really happy to go to China. I spoke PyCon China in Shanghai. It was an amazing experience to be there. I also spoke at PyCon Germany in Berlin, which was also great. And before the pandemic, I was traveling a lot speaking at Python conferences. But this year, I spoke at a few online Python conferences as well.
Digging a bit more into Fluent Python, it's quite a substantial book, and I'm curious what your inspiration and motivation was for writing it and the actual process of going so deep into all the different aspects of language and helping so many other people level up their use of the language.
The idea of the book, I love to teach. And so besides, I'm now working at ThoughtWorks, but I also offer workshops in the evenings, and also when there are events, I often submit tutorials as well. I've presented tutorials at PyCon and other conferences. Over the 20-some years that I've been using Python, I've developed a lot of materials to teach different aspects of the language. And then I realized that there's 2 things. First of all, a lot of people, this happens with any language, right? When you learn a new language, you sometimes try to apply patterns that you learned in a previous language to the new language, and that may or may not work. Sometimes it does work, and sometimes it doesn't make sense to bring that pattern from the other language to Python. So I gave a lot of emphasis on this aspect in my talks and my tutorials. I also knew that there were some interesting aspects of the language that were considered intermediate to advanced, which I thought was interesting to give more visibility to these ideas, because they actually help people understand the language better as a whole. So, for instance, the special methods, right? Also known as the dunder methods. It doesn't appear in the Python tutorial, for example. You can do the whole Python tutorial, they talk about dunder init, and that's it in the Python tutorial. And they don't even, I don't remember if they, certainly when I read, there was no mention of the idea of special methods. There was just this convention that the so-called constructor was supposed to be called dunder init. But anyway, I realized, for instance, that once you understand a little bit of the special methods, and you don't even need to learn them all, but few examples of what the special methods do and how they work and the purpose that they serve in the language, suddenly a lot of things make sense in the language in ways that are amazing. So I think one of the more original aspects of Python, of Fluent Python, certainly by the time I wrote it, I don't know, this changed, but at the time, I think it was the only book in the market that talked about special methods in the first chapter. The first chapter is really an introduction to what special methods are all about. So, and all of that, both the thing about understanding patterns that make or may not make sense in Python, and also understanding a little bit of the inner workings of the language with special methods and so on. Like I said, I've spoke a lot about those things in talks and tutorials, and I actually created a course about 7 or 8 years ago that was called Python for People Who Know Python. And basically the book is an outgrowth of that. It's a book intended for people who already know the language and are probably using it in their professional lives, but want to understand more. That was my motivation. Writing a book is super hard, but one advice that I followed from another book called, what's his name now? He wrote a book called Graphic Java. David Geary. Yeah, his name is David Geary. He specializes in writing books about graphics. And one of his books, in the preface, he says that his approach to writing a book is to think about at the start of the chapter, think about the topics you want to cover in the chapter, just an outline. And then you develop the examples you're going to use to explain that. And then the text flows around the examples, right? The text is to explain the examples. So I think this is a very useful approach, and I recommend anybody who's going to write a book about programming to follow it. Just, outline, then the examples, and then the text. I call it example-driven writing, right? Having the examples first and then having to explain them kind of focuses your writing in the essentials. This is what I need to explain. And things that maybe you find interesting but are just curiosities don't need to appear in the main body of the text. In my book, I put those things either in footnotes or in sections at the end of the chapters called soapboxes, where I'm more opinionated.
Yeah, it's definitely an interesting approach to constructing it because, as you said, it gives you something to focus on as you're going through the chapter, so that if you are just going prose first, it's easy to accidentally veer off into side channels that aren't necessarily relevant to the topic that you're trying to cover. Whereas if you have something to focus your attention that you're driving toward and you're structuring the prose as a means to get to the example and explain the example, it definitely allows you to stay more focused. And also, to your point about Fluent Python being a useful resource for people who are already familiar with the language and want to increase their facility with it, it's definitely a valuable addition to the overall canon of resources that exist for the language, because it's generally very easy to find a lot of resources for newcomers to a particular language or newcomers to programming. And then you might also find resources that are very advanced, but it's often difficult to find that intermediate range of content. And the fact that you have such a substantial amount of information in Fluent Python to help those people go from beginner or intermediate through to advanced and expert level is definitely a valuable addition to the ecosystem.
Totally. I think that's the reason why it sold so well, because I was lucky at the time when I wrote it. The two books that had more advanced Python content, which was David Beasley's Python Essential Reference and Alex Martelli's Python in a Nutshell. Those are books that go into details like descriptors and metaclasses and things like that. They were very outdated at the time. They were like, the latest releases of them were like 7 years old at the time. So there was a need for some more updated content in that area. And it's interesting, as I'm working now in the second edition, the focus on the examples means that a lot of changes in the second edition. We can talk about that soon. But what I want to mention now is that in several cases, I actually simplified examples from the first edition. Because then, having a critical look at it a few years later, I realized, oh, you know what? This feature that I added in this example is a distraction. Some easier way, be just hard code something. Just yesterday, I was dealing with an example that had to do with dynamic attributes and exploring JSON content by implementing a class that dynamically creates objects with the attributes of the JSON objects. And I realized that there was a part of the original code that had to do with downloading this data source. And I said, well, this is totally, there was like a 1.5 page in the book with the listing of that part, an explanation of it. And I said, I don't need that. Just put the data in I can do that because it's an O'Reilly data source. So I just put the data in the example code and just load it with the file read. That's just one example. I continuously updated the examples, and in some cases simplified them.
Another interesting aspect of being an author of a technical book, particularly about a programming language, is that the subject matter doesn't stand still. There are continually updates to the language and updates to the uses of it and updates to the particular use cases and topics that developers are interested in. And that's definitely one of the more challenging aspects. And I think that because you do also cover a lot of the foundational aspects of Python, it's something that has aged very well because Dunder methods are still as valid today as they always were. But sometimes there might be new Dunder methods added, or sometimes they might be deprecated. And that brings us to the topic of what has changed in Python, particularly since you wrote Fluent Python, but also just in terms of your overall career and perspective with the language. And I'm wondering if you can just give a bit of an overview about what you see as being the biggest changes that have occurred in the Python language and community in recent years. And I'll let you determine what that range actually is.
Yeah, so my book came out in 2015, right? Python 3.5 had not been released by the time I finished the book. It was like in alpha at some stage. And the biggest change that happened was actually in Python 3.5, which was the addition of the typing module and support for static typing in the language, right? Of course, that was something that was kind of slow to catch on, because it was a major change and because the tooling around it, because it requires external tooling, was not, was kind of evolving, let's say it, at the time. So anyway, but certainly over the years, this has become the major new thing in Python that professional development teams have adopted as something that you have to have in your code base. And it was a change that was sponsored mostly by companies that do have huge code bases, right? So Guido at the time was working at Dropbox. They apparently have millions of lines of Python code. And also there were type checkers developed at Google and Facebook. So these three companies are companies that have huge code bases in Python. They hired Guido was already working at Dropbox, but invited Lehostalo, I don't know how to pronounce his name. But anyway, that was the guy who created MyPy. MyPy was his PhD dissertation. And so Guido invited him to work for Dropbox. And of course, what they were working on was the typing system, right? So that was the major thing that appeared. And the other thing that was an important change was asynchronous programming with async and await. I wrote about asynchronous programming in the first edition. It was something brand new at the time, but it was done with the yield from keyword. And the API also changed a lot because although the async.io module was part of the standard library in Python 3.4, it was provisional. And in fact, the only pieces of code in the book that broke over the years were the examples using async.io, because async was the name of a function, for example, in async.io, and then it became a reserved keyword. And the API changed regardless of that in other aspects as well. The API improved a lot, actually. I haven't written that chapter yet or updated it, but it's going to be a major rewrite and it's going to be simplified. I mean, the explanations are going to be simpler, I think, because the API is easier to use. I also created more examples during those years as I talked about asynchronous programming in different events that I'm going to use in the book. So I think those are the two major changes. Now, I have to say, because if people follow me on Twitter, they may know that sometimes I get involved in some discussions about new features of Python. I now can say that I enjoy the static typing system of Python. Okay? I think with Python 3.9, it got to a place where I really like it because we have the built-ins like list, dict, and so on, supporting the square brackets for generic, so you don't need to import so much stuff from the typing module. And another major improvement was the addition of protocols in Python 3.8, typing.protocol. Without that feature, it was just not possible to annotate Pythonic code completely before. You either had to dumb down your code to become more Java-like, or you didn't annotate it. That was the situation, because Python is a language that supports dynamic typing, and duck typing is part of the essence of how you program in Python. And if the static type system has no support for duck typing, then it's very limiting. And so now I'm happy with the type system. But I'm still not happy with the fact that some people who are type system or static type evangelists keep pushing the idea that everybody should use it and that it's almost like a blasphemy not to annotate all your code with types. And I think that's not good, because for different use cases and different contexts of use of the language, the type system introduces a complexity. It always introduces a complexity, but the benefit you get from it varies a lot depending on your context, right? So for people learning to program for the first time, especially if they are not computer science majors, right? Because people are learning to program in all areas. Now there's digital humanities, for instance, right? And data science and scientific computing. So there are many other areas where Python are used and that are actually key to the recent growth of the language. It's the growth of the language in those other areas, apart from regular server-side or infrastructure programming. In those areas, it's debatable, the benefit of annotating everything with types. There's certainly a cost that is higher to people that don't have a computer science background, to learning about concepts like generics and covariance and countervariance and so on. That's what I wish we had, more balanced. It clearly says in the main peps of typing that it's always going to be optional, but there are certainly areas or places where treating it as completely mandatory. I actually think that even in situations where you have professional developers, with a lot of programming experience and computer science backgrounds and so on, choosing to annotate 100% of the code base a mistake. Because I actually found a paper that I quote in my book. So the paper is called Static Typing Where Possible, Dynamic Typing When Needed: The End of the Cold War Between Programming Languages. And it was written by Eric Meijer and Peter Drayton of Microsoft in 1994. The abstract of this paper is really short. It says, this paper argues that we should seek the golden middle way between dynamically and statically typed languages. And let me just give you one example. So this is actually happening. What we see is there's a kind of a limited but real conversions. We have languages like Python and Ruby that have always been dynamically typed, suddenly adopting static typing mechanism that it hasn't appeared yet in Ruby, but in Ruby 3. And then we have TypeScript, which is basically a superset of JavaScript with static typing. And also, on the other hand, we have languages such as C# and Go and Kotlin, not all Kotlin, but I will explain that in a minute, one variant of Kotlin. These three languages have a way of declaring a variable of a type that is dynamic. You basically have a way in Kotlin and C#, the type is called dynamic, and in Go it's called the empty interface. So it's the interface keyword with an empty brackets besides. So basically, when you declare an argument or a variable of those types, you're saying anything goes, okay? And then to make that work, those languages have runtime mechanisms to actually inspect what is there and then handle whatever is there. And why does that exist? In Go, the reason is to make it easier to talk or to write Go code that handles data source that may be unstructured or semi-structured, like JSON, right? In Kotlin, the variant of Kotlin that has the dynamic type is called Kotlin JS, is the one that targets JavaScript. So the compiler generates JavaScript code. And the reason why they added dynamic to that variant of Kotlin is to make it easier for Kotlin JS code to interface with the whole ecosystem of JavaScript languages, right? That sometimes have APIs that are difficult to annotate, just like we have in Python. Some APIs that are traditional, that are extremely popular, like requests, that are super hard to annotate because of the way it handles all kinds of different parameters and so on. I totally believe in this. The paper goes on to say that it's a fact that static typing brings lots of benefits, but it also reduces the expressiveness of the language. There are some things that there's Python code that you can write that you cannot annotate. For instance, the type system in Python doesn't support recursive types. So that's why actually there's no good way to annotate dynamic JSON in Python. If you're trying to annotate something that may return a JSON structure that has nested dictionaries and lists, if you don't have recursive types, you just can't express that in the type system. If you go to the radical approach of saying, no, in this team, 100% of the Python code must be annotated, that's going to generate unnecessary suffering for the developers. Actually, that's the same thing with automated testing, right? It's great if you can have 100% coverage, but it's not a very good idea to aim for it, because sometimes there are some tests that are super difficult to write, and they're so expensive that they are not justified, just the expense of writing those tests. So it's the same, I think, with typing. It's good to be aware that it's not a cure-all, is not something that is good for all teams, and even for teams of professional developers, there are situations where it's better to, okay, you know what, I'm not going to annotate this function because I really like the way it works. It's very expressive, but it's not worthwhile to annotate it.
Yeah, I definitely appreciate the typing capabilities like you, and I can agree with the sentiment that it doesn't make sense to have a sort of draconian mandate that everything has to be annotated, because there are, like you said, a number of cases where it's not really possible to have full type coverage, and that's why you have some cases where the annotation of a parameter or an attribute is, square bracket text comma any, because, when you have those nested structures, it's, anything goes. So, I mean, you at least know that it's a dictionary, but it still doesn't provide a huge amount of value. So in some cases, what's the point of even having there in the first place? Annotating anything with any type is, essentially useless. So, typing and asynchronous programming are definitely the biggest headline changes in Python in recent years, but there have also been a number of more nuanced or smaller additions to the language or changes to the language. I'm thinking of things like the new parser that was just released in Python 3.9, or the matrix multiplication operator and the walrus operator and things like that. And I'm wondering if you can just give your perspective on the smaller changes that have been included in the language and some of the ways that it influences the way that the community develops around it, and also from the other side, the reason the growth of the community has brought on some of these additions or changes to the language.
So thank you for this question. I want to address all three of these things that you mentioned. So the walrus let's start with the matrix multiplication operator, the new parser, and the walrus operator. So the matrix multiplication operator, I think, is a great addition because it's something that is completely harmless to people who don't need it, and it's super useful for people who need it, right? I think it's an example of the core developers being responsive to a community that is one of the most important communities of users in the Python world, who are the scientific computing community and then the data science community also. And it's very interesting that it's an operator that has been implemented in Python 3.5, but there is no, at least as far as I know, no use of it in the standard library. Nowhere in the standard library there's code that uses that operator. It was designed really for external libraries that needed it. And I cover it in the book and give an example of it. I already did in the first edition as well, because I thought it was interesting. That's when I used the alpha version of Python to test that. But, okay, so this is, I think, a very minor but good new feature. Of all the topics in computer science, programming languages are my favorite topic. So I like to learn about how they are designed, how they are implemented, how interpreters and compilers work, and so on. And I think the PEG style of parser, which the new parser is a PEG parser, is a great new development in computer science as a whole. It's a recent thing, I think 21st century, the PEG parser. It's a welcome development. What worries me about that development is that I recommend to everybody who wants to understand the philosophy of Python, beyond, of course, the Zen of Python, is PEP 3099, things that will not change in Python 3000. It was created in 2006. So Python 3000 was the nickname at the time of the version of Python that was going to be backwards incompatible with Python 2, and that eventually became Python 3. Right? They didn't want to commit to a time frame, so they called it Python 3000, like Python in the year 3000. And one of the things that this PEP says, it says no braces, okay? We are not going to introduce braces ever in the language for the purpose of delimiting blocks, and so on. But one of the things that it says there is the parser won't be more complex than LL1, right? So LL1 is a category of parsers that are the simplest parsers, and that was how the Python parser has always been before they adopted the PEG parser. So the PEG parser is more expressive. What they say in this entry here, the parser won't be more complex than LL1, is simple is better than complex. This idea extends to the parser. Restricting Python's grammar to an LL1 parser is a blessing, not a curse. It puts us in handcuffs that prevent us from going overboard and ending up with funky grammar rules, right? So this was considered a feature, the fact that Python had a limited parser. And I used to say that my second favorite programming language was Ruby. Now it's Elixir. But Ruby has a very complicated parser. It's famous for its complexity. And also, so the syntax is extremely flexible. That's why it's easy to do DSLs, internal DSLs in Ruby. But I always thought it was a misfeature of the language because it allowed you to write code that was super hard to read. And I liked the fact that the Python syntax was very simple. Now, with the adoption of the PEG parser, this limitation doesn't exist anymore. And it's amazing that immediately after this new parser was accepted, now they're talking about pattern matching, which is a feature that would be very hard to implement with the old parser. Okay? So it's like opening the floodgates of evolving the languages in ways that are not so simple. So, like I said, my second favorite language now is Elixir, and Elixir is heavily inspired by Erlang, which in turn is heavily inspired by Prolog. And these are languages that are pretty much based on pattern matching. Pattern matching is part of the essence of those languages, and I love it. Okay? I love pattern matching, and I would like to see it in Python, maybe. Why do I say maybe? It's because it's maybe a very difficult feature to add to a language that already exists instead of designing the language around the feature, you know? And I think what we are seeing with this feature is kind of, I don't know what's the rush, you know? Now it's slated for Python 3.10. That's already in alpha, you know, so people serious that they want to have such a major change in the language in the next year. You don't need to use pattern matching if you don't want it. But that's kind of not true, because if the feature is adopted, then it's going to be popping up in the source code that people need to read, right? Just the fact that we already have 1, 2, 3, 4, 5 PEPs about pattern matching. One was superseded and replaced by 3 others, and then there's a 5th one that is already an evolution on top of the basic ideas. You know, it's complicated. There are lots of corner cases, and I wish people were more careful with this. One thing that somebody wrote in the Python dev mailing list that I think makes perfect sense to me is one of the things that pattern matching needs to have is a way to express parts of the match expression that are constants, right? So, for instance, in Elixir, there's a sigil, is the caret character that you put in front of the variable to pin it, to say, okay, I want to match against the value that's already in this position, and I don't want to update this with whatever value is in this corresponding position on the other side of the match, right? So it's a big part of the arguments around pattern matching is how to do that. You know, if it's sigils or some like a prefix symbol like that, or if it's keywords or rules that are super complicated about where the symbol came from. Is it a global or I don't know. And somebody said, you know what? Here's a thing that Python maybe could have, which is the concept of a constant, a real constant. You know, in the static type system, there is the final declaration. But in Python outside of the static type system, there is no way to declare and enforce at runtime that a symbol refers to a constant, right? Perfect sense to me. Maybe we should fix that first, you know? This is a simple change. This is much simpler than pattern matching. Just let's introduce a way to have constants in the language, and then we can rethink the whole pattern matching idea after that is incorporated and used, you know? Like I said, I'm totally for having a modern parser, and I like the feature of pattern matching in other languages. I'm not sure if I like it in Python, and I am afraid that the commitment to a simple syntax is going out of the window because now we have a more powerful parser, you know? And the third thing that you mentioned, the walrus operator, is something that, of course, is not as complicated as pattern matching, but it is something that has the potential of popping up across code bases. And as somebody who teaches often I teach people who are learning to program for the first time. That's not an easy feature to explain, you know. This other way of doing assignment, but this way also works as an expression. So you have to explain this idea of an expression. It's versus a statement. You know, what's the gain? I think it's so small. In my opinion, it's not a feature that is worth its cost in terms of complicating the language, but it's not something that is as serious as pattern matching. Pattern matching, like I said, I'm not against it in principle. I do think people are rushing it. You know, just the fact that we've had probably more than 1,000 messages already about it. And 5 PEPs, to me, is a serious indication that this stuff is complicated and that we should take it slow.
Yeah, I really appreciate that you went on to discuss the pattern matching PEP, because that's another thing that I've been tracking as well and wanted to ask you about. So you saved me the trouble. And to your point, too, about the complexity that introduces and the complexity of things like assignment expression to the walrus operator, one of the key benefits of Python over the course of its history has been that it's a very approachable language. It's very easy to learn the syntax and be able to explore it. And then there are multiple layers where you can dig deeper using things like the Dunder expressions or metaprogramming and abstract base classes. And I'm wondering what your thoughts are on how the current evolution of the language affects that selling point and the challenges that you see people come up against who might be familiar with Python and have been using it since maybe the 2.x days or started with 2.7 or earlier versions of Python 3. What you see as being the cognitive cost of learning and trying to incorporate some of the new capabilities of the language and some of the attrition that might lead to.
So one thing that I think the community needs to recognize is the ease of learning Python is its strongest point, right? And the fact that it was adopted. So how is it that Python is so successful today? You know, if you look at Ruby and Python, do a Google Trends search over the last 15 years with Ruby language and Python language, you're going to see those languages having a kind of a parallel growth for a while. And then Ruby went into decline. And at the same time, Python started to take off faster, right? To become like now certainly one of the top 3 languages in the world. It's super hard to evaluate that, but different statistics and publications put it in the first, second, or third slot, right? So what happened? Data science happened. But how did data science happen? Data science happened because scientists who are not mostly, computer scientists, but, physicists, chemists, biologists, engineers of other areas, materials engineering, other areas of engineering, and people in the humanities. Anyway, users that are not the typical users of what Ruby users are even today, or Python users were at the time, like 15 years ago. Basically, physicists at first recognized the value of having a glue language that was simpler to use, to learn, to glue functionality implemented in Fortran or C++, right? And Dave Beasley made a huge historical contribution to that because he was the author of Swig, and there was a library to do that, to bridge C++ code bases with Python. And so then the scientists started building these bridges and using Python as this glue language. And then when data science or machine learning emerged, I'm old enough to remember the old AI trends in the 70s, where it was all about symbolic computation. And then there was a lot of promises that were unfulfilled. And then there was a time that was called the AI winter in the 80s, early 90s, because all the funding went away from AI because too many unfulfilled promises. And then this other area of research appeared that was called machine learning. And I remember my first reaction when I said machine learning and I read what it was, I said, okay, so there's two things to say about that. First, they were smart enough to not use the AI term, which was kind of had a bad reputation at the time. So machine learning is a good alternative name. And the second thing is they are using a completely different approach, which is not symbolic computation at all, but numerical computation. So that was the gist of what machine learning was about as a major trend in computing. And it turned out that there was this language that was very high level and that had already a huge ecosystem of libraries to do, for instance, linear algebra that are the foundations of machine learning, and that those libraries already existed in Fortran and C++, and they were bindings for Python that had lots of users that worked well. So that's how Python took off. But at the origin of this story is the fact that the language is approachable, right? The physicists picked it because it was approachable. And then everybody else started using it using Python because it was approachable and because it had the backing of the scientific computing community developing all the libraries that turned out became the core of what machine learning is, but they were not designed for machine learning. They were just, general scientific computation libraries. And then, of course, a whole ecosystem designed for machine learning specifically was built on top of that. So this is really the crown jewel. The reason why Python is successful is because it is approachable to a wide variety of users. And that's why too much emphasis on typing for me is bad, because it may scare away new users of the language. It worries me that some changes I must say that there were changes made in the language that are super sophisticated things that were added to the language in a way that didn't affect negatively the life of users. And that was, for instance, Python 2.2, when the new style classes were introduced that had the concept of descriptors, which is underlying technology of properties, but also the underlying of technology of ORMs like the Django ORM, where you declare fields in a database table. So descriptors were an addition to the language that made it super powerful. And also meta classes also at the same time with the Python 2.2. But there were things that you didn't have to learn to use the language. At the time, when Python 2.2 was released, actually for me, it took several years to actually go and study meta classes and descriptors, because I was an occasional user of properties, and I was a regular user of Django and its model classes. I never stopped to think about what that meant, really, and I didn't need to. I was happy coding my Django classes without knowing what a descriptor is. And so I think this is a characteristic of a good language feature. It's something that enhances the language for the more advanced users, allows the more advanced users to provide facilities for the other users, but doesn't intrude, That's what I think we need to go after. It's a problem of open source in general, right? I'm a big defender of open source, free software, whatever you call it. I'm a big defender of that, but it's a known issue that when you have volunteer developers, sometimes there's a lack of alignment between the needs of these core developers, who often work at big corporations and have, deep technical backgrounds, with the needs of other users of the tool, right? Who are less sophisticated programmers and who would have a very hard time contributing to the core of the language, or even participating in discussions like the ones that we are having about pattern matching. So there's this skew towards the needs of the more sophisticated users of the language, and I don't know how to counterbalance that. I think Guido did that for a while, but I also know that he was a supporter of the Walrus operator and also a support of the pattern matching now. So I think the steering committee that replaced Python as sort of the providing more of a vision to the language needs to be aware of these things. Because at the same time, it's obvious that features like typing and pattern matching occupy a lot of the bandwidth of the core developers, right? Just the sheer amount of PEPs. And there's more than 17 PEPs about typing, and all the discussion that goes around each PEP and the changes in the language and so on. This takes a lot of oxygen out of the room. And if you did some research, the wider community, you would probably find people would prioritize other things, like, for instance, better performance with multi-core machines, better support for programming mobile applications. Actually, that's the number one thing. If I had millions of dollars, I would provide grants for the people in the Beware project and other projects that are aiming to make Python a viable language for mobile development. I think this is the biggest weakness today.
Yeah, and as a somewhat tangential aspect to mobile development and multi-platform usage is also the question of packaging and distribution, which has been solved for some cases, but is still a glaring absence for others, particularly in terms of distributing applications to end users, which is something that there is ongoing work for, but as you said, it doesn't seem to be taking the kind of center stage for the people who are driving the direction of the language.
Oh, yeah, totally. It's interesting because that aspect that you mentioned, the packaging and ease of distribution of applications to end users, and the other one that I mentioned about better multi-core performance, are probably two of the key reasons why a lot of people who like Python are now using Go. Because it's just such a pleasure to write something and compile it into a static binary, and give it away, deploy it, whatever, is a static binary. Awesome. Yeah, the story of packaging in Python has always been problematic. So Dropbox obviously solved that problem, right? Because I think Dropbox still uses Python in its client code everywhere, in all platforms, or at least in all desktop platforms. There's a Python interpreter hidden inside the Dropbox app that you install on Windows, Mac, and Linux. But I wish they contributed that technology or some of the technology they developed over the years to do that. But maybe they do, I'm not aware. But yeah, you're right. Like I said, I learned to program when I was 16 years old. Recently, between writing the first and the second edition of Fluent Python, I thought about writing a book for introducing programming, right? And then I was thinking of doing it maybe in Python, but then I discarded Python because of the lack of easy support for packaging applications for mobile platforms. I think because I was thinking, if I was today 15 or 16 years old and I was interested in learning to program, I would want to learn to program for the smartphone, right? For me, this would be appealing. But writing programs that basically print stuff on the terminal, for several weeks of learning to program is not so great. And then doing web development, which is something that, when I was learning to program, I wanted to be able to show the things that I was doing to my family and my friends and have them find it interesting at some level. And it's hard to show something that's printing out stuff in the terminal to somebody else who is not in IT and they find it interesting. Well, anyway, now I'm writing Fluent Python again, but I do plan to I'm not saying I'm going to start a new book immediately. This is such a marathon. I need to have many months away from the commitment of writing every day. But I do have plans for content for teaching people to program from scratch. And I hope that when I do come back to this project, Python is better suited for that. And I think a way that it would be better suited for that would be to have better support for mobile applications.
So there are a number of other topics that I'd love to dig into with you. It's definitely been fun exploring this subject matter, but just wanted to see if there's anything else in terms of some of the recent changes to Python or features or changes to the language that you're particularly keeping an eye on or invested in or worried about that we didn't discuss yet that you'd like to cover before we close out the show.
Yeah, like I said, when I talked about concurrent programming with multiple cores, there's been some discussion and even a PEP written about subinterpreters, which is apparently kind of a dormant feature of the Python interpreter that's been around for many years. But the idea is now to expose it to end users. There's been a lot of discussions about it, that people were saying that it was difficult to implement it in a way that didn't break external libraries. And that's where our really the strength, right? When we talked about data science is in the external libraries. We can't afford to break them at all. That's probably the main reason why PyPy is not more popular today, is because of incompatibility with third-party libraries in C and Fortran and so on. But anyway, so I wish there was a solution to this problem of multi-core programming, but I do want it to be well considered and something that will not break. We don't need any more breakage. Actually, I think one of the things that I like to say to people that are newer than I in the Python world is that everybody has been through the trauma of the Python 3 migration, right? Python 2 to Python 3. And I want to say to everyone that this is not typical what happened. Because I was around when Python 1.5 became 2.0. There was also like a transitional version 1.6, which was sort of like 2.6 and 2.7 that backported some features of Python 2 to Python 1 at the time. But the transition was super smooth. Most programs just simply continued working with the transition from 1.5 and 1.6 to 2.0. And really some very advanced things broke, but most user code just worked. And then when the new style classes were added in Python 2.2, that was also done in such a wonderful way that basically nothing broke. And so that's, I think, this commitment to backward compatibility was always very much part of the core developers. And I think they still have that. They decided to do Python 3 basically to fix the Unicode issues. I was totally supportive of that change. I do think it was obvious that the cost was huge, but I don't think we're going to see that in the future. And I think we're going to have a smooth evolution of Python. And so with that in mind, I hope the language continues to evolve, but I think we should be careful about things that break existing code and also things that make it harder to teach the language.
Well, for anybody who wants to follow along with you and get in touch, I'll definitely have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the Magic the Gathering Arena platform for being able to do online play. I think they did a really good job of making a pretty polished product with that. So for anybody who's interested in trying out something to play a game and maybe interact with some other people, it's definitely worth taking a look. And so with that, I'll pass it to you, Luciano. Do you have any picks this week?
Well, I really enjoyed very much watching The Queen's Gambit. I think it was wonderful in many aspects. I was really thrilled to read that the sale of chessboards and chess books increased because of the miniseries. I recommend everybody to see it. Yeah.
Well, thank you very much for taking the time today to join me and share your experience working with Python and your perspective on the ways that the language has changed and evolved over the past few years. It's definitely been a lot of fun, and I definitely would like to have you back anytime you're interested. So thank you for all of the time and effort you've put into helping to educate the Python community, and I hope you have a good rest of your day.
Thank you so much, Tobias. This was a pleasure for me too, and I look forward to talking to you again. Bye-bye.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.